Hi, welcome back. In this video, we'll close out chapter 6, slides 30 through 34, and then there's also a mini exercise associated with this video. So why don't we talk about that briefly? It relates to beta, right? We talked about beta as our measure of market risk. High beta stocks have more market risk. And so the question for the mini exercise relates to, do we think high beta stocks or low beta stocks are going to be good over the next year? To illustrate that, maybe we'll just contrast a high beta versus a low beta stock. Here's Kimberly-Clark Corporation. They make all kinds of paper products. Scott paper towels, Huggies diapers, Depends undergarments, Kleenex, things that people buy regardless of whether the market or the overall economy is doing great or terrible. So as a result, Kimberly-Clark has a low beta, 0.54. So that Kimberly-Clark's return moves about half as much as the market on average, right? So when the market goes up 1%, Kimberly-Clark goes up 0.54 on average. When the market goes down 1%, Kimberly-Clark is down down 0.54% on average. Yeah. So contrast that with a high beta stock that I just found, Axsome Therapeutics. Play guess the ticker as you will. Axsome Therapeutics, some biopharmaceutical company that has a lot of market risk. Its beta is 3.27. So it moves way more than the market because its beta is greater than 1, right? So market goes up 1% on average. Axsome is going to go up 3.27%. So I suppose the answer to the question that's being posed, do we want to invest in low or high beta stocks? It depends on whether we think the market is going to go up or down in the next year. So let's develop an equation that we can use to measure a stock's discount rate, right? Because we talked earlier in the course, higher discount rates are associated with riskier investments. And to do that, we'll think about a couple things, right? Or revisit a couple things. A risk-free return, right? The least risky investment we could find. The T-bills that we said are negative, never negative. Right? We'll consider those to have like no market risk, right? And then the overall market return, the S&P 500. And then we already talked about the market risk premium. If you go back and look on average, stocks have outperformed the risk-free investment by 8.4 percentage points per year. Right? So the market risk premium is this 8.4% number. On average, the overall market, which has a beta of 1, has outperformed the risk-free investment, which has a beta of 0, by 8.4 percentage points per year. So that is the market risk premium. And so the equation we use to illustrate the relationship between a stock's market risk and its discount rate, its expected return, is called the capital asset pricing model. And then here's a graphical illustration of it. So we've got beta on the x-axis, right? And then a stock's expected return or its discount rate on the y-axis. So higher beta stocks with more risk should have higher average returns, we should think, right? And so to characterize that, we have like a linear relationship between market risk and a stock's expected return. So an investment, if we look at the y-intercept, an investment with no market risk, the risk-free return, in this stylized example, we've got a risk-free return of 4%, right? And then on the x-axis, as beta increases, a stock's expected return increases on average, right? And so why don't we illustrate this with, get to the equation and illustrate how to use it, right? Here it is, the capital asset pricing model. It's interesting to me because it shows that a stock's discount rate, right, or its expected return, depends on one risk measure, beta, not standard deviation, which includes company unique risk, right? We're assuming people are diversified so that a stock's expected return under the CAPM depends only on market risk, and then also what could I earn on an investment with no market risk? And then this market risk premium, this whole thing in parentheses is called the market risk premium. How much extra return do I get for taking on 1 unit of market risk, going from an investment with no market risk, the risk-free return, to an investment with a beta of 1, the overall market. So let's illustrate how that works with this example. So suppose a stock has a beta of 1.5, more market risk than the market. We've got the risk-free return and the overall market return. Compute the stock's expected return, or compute the stock's discount rate, in other words. If we have the equation, it's pretty straightforward to do, right? So let's just illustrate that. Example 6.5. All right, so this stock's expected return is going to be equal to the risk-free rate, we said is 3.5 or 3%, excuse me. Let's decimalize the percentages always, plus the stock's beta is 1.5. And then we multiply that whole thing in parentheses by the difference between the market return, 12%, and the risk-free rate, 3%. And so RM is 0.12, and then RF is 0.03. And you plug that in and you do all the math and you come out with the stock's expected return, right? Why don't we do the math real quick? So maybe I'll do 1.5 times 0.12 minus 0.03 is 0.09, yeah? Do that right-hand term first, and then add to that the risk-free return, add 3% to that. I'm getting an expected return of 16.5%. Either way is fine. Decimalize, percentagize, whatever you want to do is fine, okay? So a stock like this with 1.5 units of market risk, a beta of 1.5, should earn on average a return of about 16.5%. Well, that will do it for Chapter 6. Thanks for tuning in. In the next video, we'll review for the second exam. Thanks.